Hello, this is the lesson 1.1 explainer, and we're going to be going over motion diagram, velocity, acceleration, and displacement. This problem, Sam is recklessly driving 60 miles per hour in a 30 mile per hour speed zone when he suddenly sees the police. He steps on the brakes and slows 30 miles per hour in 3 seconds, looking nonchalant as he passes the officer. How far does he travel while braking? That's the picture. Concepts we're going to be going over are velocity, change in position or displacement. Velocity is the directional speed of an object, and displacement is the change in position. We want to know how much distance Sam traveled, so we must find the displacement. Displacement can be shown by, we're going to show displacement by change in d. So for this problem, we can use a kinematic equation, and since we don't know the acceleration, we're going to use this one. Change in distance equals velocity final plus velocity initial over 2 times t, which is time. To find how far Sam traveled, we need to find the average velocity, which is the velocity initial plus velocity final over 2 part of our equation is equal to the velocity average. So we know this is 60 plus 30 over 2, which is equal to 45. And for our problem, we remember that it is times t. So it's going to be 60 plus 30 over 2, change velocity average times t, which is 3, which is 45 times 3, which is equal to 135, which is equal to our displacement, or our distance traveled is 135 feet. So the distance covered by an accelerating object could also be found using a velocity time graph, which I'll draw right here. 1, 2, 3, 4, 5, 6. Here. Remember, we start here and we end here, and then he keeps going this way. Now, I found while researching how to do this problem, I found an interesting thing on the internet that this right here is a trapezoid. And if you use the formula for a trapezoid, is base 1 plus base 2 times 2 times height, divided by 2 divided times height, which is pretty similar to this equation. So I thought that was pretty interesting, because if you solve this out, this is a good example. You can solve a problem by looking at it from a lot of different angles and perspectives. There's not always necessarily just one exact way to do something, but knowing different ways to get to a problem can always help you if you don't know exactly how to get there, but looking from the problem from different angles. So that's lesson 1.1.